In this problem, we are given a radical equation formula that describes the time it takes an object to fall a certain height in feet. Um, and notice that we take that height, we would divide it by 16, and then find the square root of that quotient to determine that time it takes the object to fall. So in part A, we're told if a ball is dropped off a cliff that is 576 feet tall, how long will it take to hit the ground? What we're given here, the 576 feet, is the height. And notice that that height is in the correct units that it needs to be for the formula. So for part A, we will substitute 576 in for height. The next step we're going to do is really there's understood parentheses here if we're following this order of operations. We need to divide 576 divided by 16. That would give us 36. And then we would need to take the square root of 36, and the square root of 36 is 6. This time is described in seconds, and seconds is already selected here as part of your answer. Notice anything in blue you may need to use. So it does say simplify your answer, type in an exact answer, use radicals as needed. In this case, the square root of 36 is a perfect square, so we get this whole number 6. Part B is just a little bit different. So the height has now changed to 700 feet. And notice also in the equation it says exactly how long will it take to hit the ground. You're told to type your exact answer using radicals as needed. So the first thing we do is divide 700 by 16, and you notice that you get some decimal answer. Well, that's not going to exactly be what we need because we need to simplify our answer but not use any decimal approximations or anything like that. So what I suggest we do is use one of those properties of exponents. Remember, a radical really is an exponent, where we can rewrite this fraction like so. And the reason I'm doing this is because I know I can take the square root of 16 and get a whole number answer because 16 is a perfect square. So that will lead us to the square root of 700 divided by 4. Now we can focus on finding the square root of 700. Well, 700 is not a perfect square. So this is where we would want to break down 700 into its factors that we can find some type of perfect square within it. You could go as far as breaking it down to its prime factors if you're unsure where to start or where to stop, because prime factors would be where you stop. So that's the method I'm going to use. So knowing that 700 is a multiple of 100, and 100 is divisible by 25, I just chose to divide by 25 first. There was not really a whole lot of rhyme or reason other than that. But I'm going to continue breaking down these factors because 25 times 28 gives me 700. I'm going to break down the 25. It would be 5 times 5. The 28 could be 7 times 4. And the 4 could be 2 times 2. So now I have 700. I can rewrite it as a product of its prime factors. Notice that's anything on the ends of these branches after we break down 700. I'll just put them in order as well. 2 times 2 times 5 times 5 times 7. I do recommend that you take a second to check to be sure that that does give you a product of 700. So up next, if we're going to take the square root of these prime factors, what we could look for are pairs of factors. So let me rewrite that. And it will look like this. I'm just taking the square root of 700 or the square root of the prime factorization of 700. And I'm looking for pairs of factors. I can pull out one of those factors in front of the radical. Here's another pair. I'll multiply by pulling out one of those factors, and then whatever does not have a pair stays under the radical, like so. 2 times 5 becomes 10. So 10 square root of 7 is the exact simplified form of the square root of 700. I can verify this on my calculator real quick. So here I'm typing the square root of 700. Next, I want to type 10 square root 7. And notice that their decimal approximations are the same for what I see on my calculator, so I'm pretty confident that I have correctly simplified this radical in an exact radical form. So now, remember, this was all side work, scratch work, in order to simplify what we had in our numerator over here. So I can rewrite that numerator as 10 square root 7 over 4. And the 10 and the 4 both have a common factor of 2. So when I divide both of these by 2, I'm left with 5 and 2. So in the end, we have 5 square root of 7 over 2 as our final exact answer using radicals.